Hello all. In today's video, we are going to learn about the data link layer, its responsibilities and framing techniques. What is a data link layer? Before learning about what a data link layer is, let me remind you that there are 7 layers in a network model, that is the OSI model. We have the physical layer, the data link layer, network layer, transport layer, session layer, presentation layer and the application layer. What is the responsibility of a physical layer? The responsibility of physical layer is to transmit the raw bit stream over the physical medium. In the previous videos, we have learnt about what a transmission medium is, what are the different types of transmission mediums, guided and unguided. Now let us move on to the responsibility of a data link layer. A data link layer is responsible for transforming the raw transmission facility into an error-free link. So majorly the responsibilities of data link layer include framing, physical addressing, flow control, error control and media access control. What is framing? Framing is that the data link layer divides the bit stream into manageable data units called frames. So it is called as framing. What is physical addressing? The data link layer is responsible for addressing devices locally. That is, it gives a physical address to a device called as the MAC address, which is generally imprinted on the network interface card. What is flow control? Data link layer is also responsible to optimize the flow control between the devices, meaning the fast sender should not overwhelm a slow receiver. Error control. Error control is, as I have already told you, that the data link layer transforms the raw transmission facility into an error-free link. How? By doing error control. By doing error detection and error correction, the data link layer transforms the raw bit stream into a reliable link. What is media access control? Now, we have a medium available for access by different devices. If we have a single medium connecting many devices, which device uses the medium or the link for data transmission has to be decided, and that is done by media access control, which is one of the responsibility of data link layer. Now, in this video, we are going to learn about the different framing techniques. What is framing? Let me tell you again that framing is that where the data link layer divides the stream of bits received from the network layer into manageable data units called frames. In simple terms, the data link layer is responsible for moving frames from one node to another. Now, let us look. Framing can be done in two ways. Either we do fixed size framing or we do variable size framing. In fixed size framing, the size of the frame is fixed. So there is no need of defining any boundaries for the frame. In variable size framing, the size of the frame is variable. So it is required that we need to define a way to find out the end of one frame and the beginning of next frame. For variable size framing, or for grouping the frames with variable size, we have two approaches. We have the character oriented approach or the bit oriented approach. The character oriented approach is called as character stuffing and the bit oriented approach is called as bit stuffing. So the framing techniques which I was talking about, there are two: character stuffing, also called as byte stuffing, or the second one is bit stuffing. Now, before going to byte stuffing or character stuffing, let us look at the character oriented approach, wherein let us have a look at the frame format. When we have said that we are grouping the bits into manageable units or groups called as frames, then how does a frame looks like? A frame has the data that has to be transmitted, the actual data that has to be transmitted. Along with that, of every frame has a beginning and an ending flag. The purpose of a beginning and an ending flag is for delimiting the frame, meaning for specifying the beginning of the frame and for specifying the end of the frame. The header of the frame generally contains the information about the physical address of the devices, both the sender and the receiver. And the trailer consists of the information about error control. As I told you that the data link layer is responsible for framing. So we are having flags, the beginning and ending flags for framing, and we have header information which consists of the physical addressing, and error control, that information comes in the trailer of the frame. And in between what we have is the data that has to be transmitted. Data from the upper layer means data from the network layer coming to the data link layer. Now, okay, so let me tell you what is byte stuffing or character stuffing. Now, in byte stuffing, what we do is we add an extra 1 byte whenever a flag or escape character appears in the text. Now, see, if we have, this is our frame. What does a frame consists of? The data that we are transmitting. Okay, and what does a frame have in the beginning and the ending? The frame has flags in the beginning and the ending, where a flag byte specifies some bit pattern, special bit pattern. There is a possibility that the same bit pattern used for flag may appear in the data. So what will happen? The receiver, on seeing the flag pattern in the data, will mistakenly assume that this is the end of the frame. So to make this receiver understand that the flag which is appearing in the data is not control data, rather it is the actual data. So what we do is we make use of an escape byte before the flag pattern. Before the flag pattern, we have an escape byte, meaning that telling the receiver that escape this flag byte as data, not as flag. Okay, this is what is byte stuffing. Now I'll give you an example. So let us look at an example of byte stuffing and destuffing. Now what we have here is we have the data coming from the upper layer. Now in the data, if you can see, the byte for flag used for flag has appeared in the data part. Now what will the receiver think when it will receive this frame? It might think it as the end of a frame. Okay, but it is actually not. So what do we do to remove this confusion? What we do is we do byte stuffing, where we are going to add an extra byte before this accidental flag that has appeared in the data. Now this escape byte tells the receiver that the byte what you are seeing is not control information or delimiter, but rather it is the data part only. Okay, then what is the other thing? You can see that the escape byte, which is actually used for uh, byte stuffing, the bit pattern for escape byte is also appearing in the data. So now this confusion also has to be removed, that this is not the escape byte, rather it is the data. So for that we stuff another escape byte before this accidental escape byte. That is why we call it as byte stuffing. So the sender, while sending the frame, when there is some accidental flag or escape bytes appearing in the data portion, we do byte stuffing, where we add an extra byte called as an escape byte before the accidental flag or escape bytes. Then you can see extra 2 bytes have been added, which will inform the receiver that escape this flag as data, not as control information. So what we do later, when the data has to go to the upper layers, we will remove this information, we will remove these bytes, and this process is called as destuffing. You can see the extra bytes are being removed and given, the actual data is only given to the upper layers. Now what is the disadvantage of character stuffing? Character stuffing basically deals with 8-bit characters. Okay, but today's systems we have unique code ranging from 16-bit to 64-bit data. So in that case we have to employ the bit oriented approach. In the bit oriented protocol we have the data section where the bit pattern does not only signify text but it also signifies graphics, audio, video and so on. Now, let us see the frame format in the bit-oriented protocol. The frame format in the bit-oriented protocol is similar to that of character-oriented protocol, but here we have a special bit pattern for the flag as 0, 6 ones and 0. We have an special 8-bit pattern flag at the beginning and the ending of the frame used as delimiter. And then we have header information for the physical address, we have the trailer information for the error control, we have the data that has to be transmitted. Okay. Now, what is bit stuffing? Bit stuffing is here we are stuffing an extra bit, that is a 0 in the data. What is the reason for doing so? Now, what we did in byte stuffing, in the data part, if the flag byte was appearing, what we were doing, we were stuffing or adding an extra byte. That is why we call it as byte stuffing. But in bit stuffing, what do? We add an extra 0 or extra 1 bit to the data. What is the reason for adding so? Now, as I just told you that we have a special bit pattern for flag, that is 0 followed by 6 ones and 0. Now this special bit pattern may accidentally appear in the data part also, because it is all a collection of bit stream, collection of bits, group of bits. The same pattern may appear in data. So if the same pattern appears in data, what will happen? The receiver will mistaken this pattern as 0610 as flag and think it as the end of the frame. So if you don't want this to happen, we will be stuffing an extra 0 bit after 5 consecutive ones. So if I have a 0 for example, and if I have 5 ones, 1, 2, 3, 4, 5, I will stuff an extra 0 bit and whatever I have after that will be as it is. So what will happen in this way? I am not at all giving a chance for the receiver to see 0, 6 ones and 0. Immediately after 5 ones I am going to stuff a 0 so that the receiver will not have any confusion about whether it is a flag or data. That is called as bit stuffing. Let us look at an example more. So let us see a clear example of bit stuffing and destuffing. Here you can see I have data 0, 0, 0. Then I have 1, 2, 3, 4, 5, 6, 0, 6 ones and a 0. Now what is this? This is the bit pattern for a flag. What will the receiver think seeing this? It will think that it is the end of the frame, whereas this is data. So if you don't want this to happen, what I do is after every 5 consecutive ones, you can see 1, 2, 3, 4, 5. After 5 consecutive ones, 1, 2, 3, 4, 5, I am stuffing a 0 and the remaining information as it is. Here also 1, 2, 3, 4, 5. There's already a 0, but still now when I have decided that after every 5 consecutive ones I am going to insert a 0. Though there is a 0 here, but we have decided that we will never give a chance for the receiver to confuse that it is a flag. So whenever we have 5 consecutive ones, we are going to stuff a 0 bit. Okay, we are going to do bit stuffing. So when at the sender side, the sender will do bit stuffing by stuffing a 0 before a 0 after 5 consecutive ones, and at the receiver side the receiver will see these extra bits, okay, and then it will not mistaken it as flag because now we have changed that pattern completely by stuffing this extra bit. So at the receiver side, while this data has to be given to the upper layers, we do destuffing where the stuffed bits are removed, unstuffed and sent to the upper layer. So this is your bit stuffing technique. In simple terms to tell, if the flag-like pattern of 0, 6 ones and 0 is appearing in the data, it will be changed to 0, 5 ones and 0, where 0 is a stuffed bit, so that it is not mistaken as a flag by the receiver. So this is how we are doing the framing of bits using byte stuffing or bit stuffing. Thank you.